My opponent's original claim was intelligent alien life exists elsewhere in the universe. Due to the size of the universe, there's a high probability that other habitable planets exist, was his first claim. His second claim was water exists elsewhere in our solar system. And his third claim was about the Drake equation. In response to his first claim, that was due to the size of the universe, there's a high probability that other habitable planets exist, it was an assumption. It does not become a question of whether there are habitable planets that exist, but rather if there is actually life on these planets. The fact that the planet could sustain life does not mean life can be sustained. As a comparable analogy, according to the womenshealth.gov, the average age for a girl to be capable of creating a child is 12. Ollie make them French leap. Though her body is technically capable of having a child, does not mean that she will have a child at that age. His second claim was water exists elsewhere in our solar system. In response to this claim, as my second claim, Jay responded that water on Mars, Mercury, Jupiter's moons, Callisto and Europa, Saturn's moons, Enceladus, and Venus once had water, the keyword being once. According to Space.com, in 2013, Mars, for instance, may be too cold for liquid water on its surface. According to Sophisticated Edge in 2013, living organisms cannot survive on Venus. The planet is toxic to carbon-based life. In order to sustain alien life, it would take a lot more than water. Simon Conway Morris, who is professor of evolutionary paleobiology at Cambridge University, claims that aliens are likely to be just like humans. If what he says is true, the planet would also need an atmosphere, oxygen, and a way for food to grow. According to Rita Jones of the Australian National University, their results show that only 12% of the volume of Earth where liquid water exists is known to host life. As for the rest of this volume, life has presumably never found a way to adapt to the conditions there, despite having had several billion years of evolution to work with. It shows that life and water are not equivalent, Jones says. Rita Jones of Australian National University also discussed that not all water is friendly to life, and in fact, there may be a lot of liquid water that is hostile to life. Though water may exist on other planets, due to the absence or lack of atmosphere and water and other variables, the water may not be in liquid form. There may not be water in liquid form, making it almost obscure for the idea of life. As for his third claim, the Drake equation, which he did a nice job of explaining, for those of you who don't remember what the Drake equation is, here's a definition. According to mathematically estimate the number of worlds that might harbor beings with technology sufficient to communicate across the vast gulfs of interterrestrial space. The equation was discovered in 1961, which is an outdated source. The equation is usually written n equals r asterisk times f to the subscript p times n to the e, f to the subscript 1 times f to the subscript I times f to the subscript c times l, where n is the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. R to the asterisk is the rate of formation of stars suitable for the development of intelligent life. F subscript p is the fraction of those stars with planetary systems. N subscript e is the number of planets per solar system with an environment suitable for life. F subscript 1 is the fraction of suitable planets on which life actually appears. F subscript I is the fraction of life-bearing planets on which intelligent life emerges. And then F subscript C is the fraction of civilization that technology releases detectable signs of their existence into space. But this equation dates back to 1961, as I said. Technology and evidence has been updated since. According to George Dvorsky, the integers that are plugged into this equation are often subject to wide interpretation and can differ significantly from scientist to scientist. Even the slightest change can result in vastly different answers. Part of the problem is that our understanding of cosmology and astrobiology is rapidly changing, and there is very often little consensus among specialists with variables that it might be. What this put into like a little brief is, with a wide interpretation, the numbers plugged into the equation are not completely justified and will vary from person to person and scientist to scientist. The equation also lays out certain variables that would alter the answer immensely. As a conclusion, I believe that Jay's first claim was an assumption that also, even though they may have potential to sustain alien life, does not prove that life form exists, including not limited to alien life forms. I also believe that water does not come in the form of liquid. Not all water is hostile, and aliens would need more to survive than just water. And the Drake equation is outdated, and the equation is subject to a large interpretation. Thank you.
The Drake equation couldn't tell you that that table was going to be right there in front of you. The advocate's claims are labeled pretty clearly. Internal structure is easy to follow. I think that you do a good job on the first point explaining the assumption that's built in there and making a general argument about the ability, having water or the ability does not necessarily automatically equal life. I do think that the comparison that you make about the 12-year-old girl is an interesting one. I just think that it's not necessarily as convincing as it could be, and if there was some other way to explain it, I think it would help. The other points, on the other hand, I thought you did a good job explaining. On the issue of water on the planets, you have a good conditional statement about it once having those, and then there are several counterclaims here talking about how water might have it could potentially be hostile, or that the form in which it comes is not necessarily usable, or the temperature of the planet, all those sorts of things. So I thought that those were all reasonable challenges. I don't remember what the advocate's evidence on that particular point was. All your counterclaims, though, seem to generally talk about the water issue. On the Drake equation, I thought it was a little strange that you went through you said he explained the Drake equation pretty well, and then you repeat the whole equation and give us all the integers that are being included in it. I think that's probably unnecessary. Your original argument that says it's 1961, so it's outdated, I'm sitting there wondering why. It's not until you get to the last part of the argument that you actually start to explain why, and I think that that ought to be the evidence that supports that point instead of going through that whole equation. Otherwise, I thought it was very well organized and very direct in its counterclaims.